everyone, this is Annie from the Kawartha Art Gallery. On this fifth and final episode of Projects for Kids 11 to 13, I'm going to be showing you how to make two things, a CD hovercraft and liquid fireworks. With our first one about physics and our second one about chemistry, I think it's a good ending to the week. With that, let's get started on our CD hovercraft. This project will use the power of physics, specifically Newton's third law, this guy right here, to create a balloon-powered hovercraft. You will need an unused or old DVD, a water bottle top, and make sure it's one of those tops that you can pull up and down. You can usually find them in a pharmacy or something. A balloon, and a hot glue gun. You're going to want to glue the bottom of the sports drink cap to the shiny side of the CD, and make sure that the hole in the cap and the CD are aligned so that the air can escape out of it. And then we're just going to hot glue it on. And yes, I know my hot glue gun, it looks terrible. It's like 10 years old or something, but it still works, so. And just make sure all of the glue is covering any possible holes for the air to escape. See, I have it completely covered around, as you can see at the bottom, so that nothing can escape. Now you're going to want to blow up your balloon. Here is me doing exactly that as I stare at you. Now you're going to want to twist the end of the balloon a bit, just to prevent any air from escaping, while you are using the end to hook it over the cap. And just like that, when we open the cap, like that, we have our hovercraft. See, it's quite fun just to play around with it. It kind of reminds me of air hockey, you know, those air hockey tables. And once it runs out or stops being interesting, then you just re-blow up the balloon and then stick it over again. And there may be skeptics out there who think, well, your table probably is just smooth, so the CD would have slid anyway. No, here is a comparison. Now that we have our CD hovercraft made, let's ask ourselves, how does this work? Well, Newton's third law states that with every action there's an equal and opposite reaction. So if you were to punch a wall, your hand is going to really hurt. And that's because the strength you use to hit the wall is coming right back at you. So with our CD hovercraft, the air from the balloon is pushing into the table, which is then causing an upward force on our CD. But you can't just expect to tie balloons to your feet and fly. The fact that our CD is flat allows for the air to escape in all directions, which also helps keep it afloat. Now that our hovercraft has been created, let's close off our event with some celebratory fireworks. You will need warm water in a jar, which I've filled to about 2/3 full, 3 to 4 tablespoons of oil, and I'm using canola oil, and you also need a shallow dish or a bowl or something like that to put the oil into, and various food coloring, because that's going to be our fireworks, and also a popsicle stick to mix. So to start, I'm going to be measuring 3 tablespoons of oil, and I'm going to be pouring it into this shallow plate. Okay, never mind, 4 tablespoons of oil I used here. And then you're going to want to take your food coloring and just drop it around, because as you can see, it doesn't dissolve in the oil, so you can just drop it wherever, as long as it's spread out. Now you're going to want to take your popsicle stick and just mix it around, or mix it as best you can, because clearly, as you can see, it's not really fully mixing, it's just making the drops a bit smaller. And also, I'm just trying to break it up because a lot of the food coloring sort of stuck to the bottom, and you don't want that happening. Now for the fun part, we just pour it right into the jar. As you can see, all the oil is floating to the top, and you're just going to want to wait for a little bit. At first I was confused, but if you wait a little bit, you can start to see, look, isn't that cool? All of the food coloring is beginning to settle down, and it makes it look like liquid fireworks. It's quite hypnotizing to stare at if you just keep looking at it. And so everyone, that concludes our final project of this week-long journey for kids 11 to 13. Now that we've made some fireworks, let's ask ourselves, how did this happen? Food coloring, which you probably already know, dissolves in water, but not in oil. Because the oil is less dense than the water, which means it's less heavy, it will float at the top. The colored droplets will begin to sink because they're heavier than the oil. So once they sink into the water, they begin dissolving into it, which makes it look so cool. Hey, thanks for watching. This is the final episode of a series of 5, so go back and watch the rest if you haven't already. And if you have, then thanks for coming along this journey with me. And remember, kids and parents, if you did this experiment, then take a quick picture of it, email it to this email address along with the child's name, age, and title of the video, and we will post it to the Kawartha Art Gallery website and social media so that you can see your own projects featured online.